Drive systems are the core component in industrial production. In combination with sensors and software, they enable the digitalization of the production process and thus the transparency of the technical processes. In short, only with Drives 4.0 does Industry 4.0 actually work. Within the framework of a ZVEI project, Demonstrator Drive System 4.0, the interoperability of electric drive systems is now being demonstrated for the first time as an Industry 4.0 component. For this purpose, the concept is based on a technology-independent asset administration shell. Manufacturers, machine builders, and operators benefit from consistent and interoperable access to information and functions throughout the entire product life cycle.
Herzlich willkommen. Mein Name ist Martin Hankel von der Bosch Rexroth AG.
A warm welcome. My name is Martin Hankel from Bosch Rexroth AG, and I head the working group Industry 4.0 for electrical drive systems at ZVEI. In the last few years, a lot of papers and concepts have been developed within the framework of the platform Industry 4.0 on the asset administration shell, i.e. the digital twin. 8 well-known drive manufacturers, together with the Technical University of Darmstadt, have joined forces and pushed forward a first manufacturer-independent implementation of the digital drive twin. In doing so, we've drawn on our 2019 Drive 4.0 concepts and implemented them in the new Demonstrator. We're thus creating a new platform on which we can develop new functions and new services in a standardized manner. In the following, Professor Griepentrog from the Technical University of Darmstadt will introduce you to the Demonstrator.
Industrie 4.0 Funktionalität.
Industry 4.0 functionality has been integrated into electric drive systems by drive manufacturers for many years and is demonstrated in various applications and contexts. Unfortunately, however, there is no overall interoperable solution. In this respect, it was a challenging task for the Technical University of Darmstadt to implement an interoperable solution for Industry 4.0 for electrical drive systems and to show this. 2 departments of the Technical University of Darmstadt were involved. The Real-Time Systems Lab, ES, headed by Professor Andy Schur, and our Institute for Power Electronics and Control of Drives.
Unser Fachgebiet Leistungselektronik und Antriebsregelung.
The implementation in this Demonstrator Drive System 4.0 project is based on the standards available today. Each drive system has its own asset administration shell, a standardized information model with E-class properties. The respective asset administration shells are mapped to the communication standard OPC-UA. Thus, the existing proprietary properties and functions of the 8 drive systems are provided in an Industry 4.0 compliant format. The Demonstrator implements 3 use cases. The first is diagnosis in the form of an oscilloscope. During operation, the oscilloscope can be used to record a process signature of a drive system, a machine, or a line, and to evaluate it online. The saving and loading of process signatures enables the long-term evaluation of the system status. In the case of deviations, the operator can intervene, if necessary, before an error occurs in order to maintain safe operation and prevent damage. The nameplate function is based on a uniform data structure with Industry 4.0 semantics. The International Classification System E-Class was selected for this purpose. The manufacturer-independent standardization of data and function interfaces leads to flexibility, and the standardization of functions facilitates the development of machines, their commissioning and maintenance over their lifetime.
Mit dem Demonstrator und den gezeigten
With the Demonstrator and the use cases presented, a milestone in the interoperability of electric drive systems has been reached. This forms the basis for further functions, for example, energy management or advanced diagnostic procedures. We can now also think about implementing extended control procedures, for example, an electric shaft between different drives or a separation of hardware and software for drive systems. However, these procedures require that we integrate time-sensitive networks, TSN, into the OPC-UA communication platform used here. The Demonstrator is an important project to test the theory. In addition, experts at ZVEI have developed visions and described them with 12 theses in the white paper Drive System 2030. The drive system in the year 2030 will continue to develop, especially in its sensor technology and connectivity in the Industrial Internet of Things (IIoT) environment, and will be embedded in the user's value chain. The white paper can be downloaded from the ZVEI website. If you have any questions about the digitalization of electric drive systems, please contact ZVEI.